Today we're going to talk about arithmetic sequences. Number 1 says draw the fifth pattern of the stacked cubes. So let's look here. We have one cube here. For the second one we have 3 cubes. For this third pattern we have 1, 2, 3, 4, 5 cubes. For the fourth one we have 1, 2, 3, 4, 5, 6, 7 cubes. Okay. Notice that we are increasing by 2 cubes each time. So for the fifth pattern, we will have 9 cubes. Okay. So that would look like this. See, it looks like they add a cube here and here each time. So 1, 2, 3, 4. So 1, 2, 3, 4, 5. I'm going to add a cube there, and then I'm going to go up 1, 2, 3, 2, 4, 5, 6, 7, 8, 9. Okay, so we added a cube to each end there. All right. Now it says predict the sixth pattern. So for the sixth pattern, I'm going to guess 11 because I'm increasing by 2 each time. Okay. All right. So the pattern on the first, second, third, fourth, fifth, and sixth pattern, the number of cubes we have for the first pattern was 1. For the second one, we had 3. For the third one, we had 5. Fourth one, we had 7. Fifth one, we had 9. And the sixth one, we said 11. So number 4 says graph the values in the table. All right, so I'm going to label the x-axis as the pattern number and the y-axis as the number of cubes. All right, so these are the coordinate points. 1, 1, 2, 3, 3, 5, 4, 7, 5, 9, and 6, 11. Let me get that straight there. Alrighty, it looks like it's right here. Nope, missed it just by a little bit. Okay. You can see all those points though. There we go. All right. So with that said now, okay. It says write the equation of the line. All right. So this is a linear function. So y equals, my slope is up 2, right 1, up 2, right 1, up 2, right 1. So 2x. And then if I go down 2, left 1, that's going to get me at the y-intercept of -1. Okay, so that would be the equation, working backwards there. This pattern is an example of an arithmetic sequence. Okay. All right, let's talk about what an arithmetic sequence is. It's a set of numbers that increases or decreases at a constant amount. Keyword. Okay. The common difference is the constant that the numbers change by. This can be positive or negative. So just some vocab here. The first term in a sequence is denoted as a sub 1. Each subsequent term, so each term after that, is denoted as a sub n, where n is the term number in the sequence. So that was kind of like your pattern numbers up above. Okay. So let's look at this example. It says, given the sequence 1, 5, 9, 13, 17, etc., identify the following term values. So this is saying, what is the term value? Okay, so one of these numbers at a sub 1, meaning in the first term number. So the first term number is 1. The fourth term number, 1, 2, 3, 4, is 13. The ninth term number is 1, 2, 3, 4, 5. Oh, looks like we have to do some math here. Okay, so let's see what this is going up by. Looks like by 4s each time. Okay, so we need the ninth term. 1, 2, 3, 4, 5 plus 4 because we're adding 4 each time, right? So that's the sixth term, seventh term, eighth term, ninth term is 33. That's the ninth. 10th, we gotta get to the 12th. 11th, the 12th term is 45. Okay, so term number, term value. Okay? All right, sequences as functions. Since each term value is paired with exactly one term number, a sequence is a function with the following properties. The domain is the set of term numbers. Okay, so here's the term numbers, that's n. And the range, these are the term values. In an infinite set, the domain is the set of the natural numbers. And those need to be positive whole integers. Natural numbers are positive whole integers. Okay. All right, let's flip this over. So let's find the common difference and the next three terms of this sequence. So to get from 45 to 49, it looks like we're going to be subtracting by a number. It looks like you're subtracting by 6. So minus 6, minus 6, minus 6 each time to get to each of those. So the next three terms, I'm just going to subtract 6 from that. So 37 minus 6 is 31. 25 and 19. All right, so the common difference was -6, and the next three terms were 31, 25, and 19. All right, the nth term of an arithmetic sequence is this formula right here, okay? So if I want to get any term number, I can do that by taking the first term value plus the common difference is represented by D, and I don't know, yeah, we need to note that right here. So the common difference is D. That's the D value, okay? We can even note that here. Oops. And if I can spell difference. Oh no. Having some difficulty, sorry. Okay. Common difference. Okay. And then whatever term number you want minus 1. Okay? All right, so let's work that out. So it says write an equation for the nth term of this arithmetic sequence. So let's see here. A sub n will be equal to a sub 1, which is 8. That's the first term. Plus, we need to find the common difference. So to get from 8 to 17, so 7, 8, 9. So it looks like we're adding 9. 17 to 26, we would add 9 again. 26 to 35, we would add 9 again. And you guys can kind of play with that. If you're unsure, you can do 17 minus 8, that's 9. 26 minus 17, so you always want to do the previous term, 9. 35 minus 26 is 9, okay? You're just using that previous term. So the common difference is 9 times n, because we don't know n, minus 1. So this would be the setup, but you guys can go ahead and simplify this to get an equation, a nice pretty equation. So a sub n equals 8 plus we can distribute the 9. So you get 9n minus 9. And then you're just going to combine your like terms. So 9n 8 minus 9 is -1. So that would be your equation for the nth term of this arithmetic sequence. So number 7 says find a sub 15 of this sequence here. So a sub 15 meaning when n is 15, okay? So let's first find the common difference. Get to from -3 to 4. 4 minus -3 is 7. So we're adding 7. That makes sense because 4 plus 7 is 11 and 11 plus 7 is 18. So remember, these all have to match in order for it to be the common difference. So a sub 15 is going to equal a sub 1, which is -3, plus the common difference of 7. Our n value is 15 because we want the 15th term, minus 1. And you guys can just type that into your calculator. Oh, we have a little bit of a glare. Okay, so I've got -3 plus 7, parentheses 15 minus 1. 95. Okay. All right, number 8. Actually, just move that all the way down there. All right. Oh, sorry, it's a little crooked. Find the indicated term if a sub 1 equals 3, d is -5, and n is 24. So I'm just going to plug it back into that equation that we have up above. So if n is 24, that means we want to find a sub 24, because that's where n is in the equation, okay? And then I have a sub 1, which is 3, plus the common difference of -5 times n, which is 24, minus 1, and then I just am going to plug that into my calculator. So 3 plus -5, parentheses 24 minus 1, -112. Okay? All right, number 9, complete the following statement. 68 is the blank term of the sequence of -2, 3, 8. So we are actually going to find what term number 68 is. 68 is the term value. We want to find the term number, like where it falls in the sequence of this. So we know that the term value is 68. Our first term, a sub 1, is -2, plus we need to find out what the common difference is here. If you look, you're going to be adding 5 each time. Okay, so -2 plus 5 is 3, 3 plus 5 is 8. So I have 5 times n minus 1, because the term number is n and we don't know what n is. So we're kind of working a little backwards here. So now I'm going to just solve this equation. So I'm going to add 2 to both sides, and I get 70 equals 5 times n minus 1. And we can go ahead and distribute that 5. If you guys want to do the distribution first and then the add 2, you can do that as well. It does not matter. So 5n minus 5. Now I'm going to add 5 to both sides. So I get 75 equals 5n. Divide both sides by 5. 75 divided by 5. If you need to, do it in your calculator. N equals 15. So 68 is the 15th term. And we can check that by plugging n back in right here. -2 plus 5 times 15 minus 1 equals 68, which is what we wanted. Okay? All right, number 10 says, explain why the sequence 4, 5, 7, 10, 14 is not arithmetic. So let's see here. To go from 4 to 5, we add 1. 5 to 7, we add 2. 7 to 10, we add 3. 10 to 14, we add 4. Okay? In order for an arithmetic sequence to occur, you have to increase or decrease at a constant amount. Notice that we are not increasing or decreasing by a constant amount. So the common difference has to be the same. So this is not arithmetic because the sequence is not increasing by a constant amount. The D value is not the same all the way across the board. Okay? All right, that's it for your notes.